The section 1.3 is review of decimal numbers and square roots. Okay, so let's focus on decimal numbers for now. Okay, decimal numbers. What do I want to talk about? Decimal numbers. So take for example, if you have the number 23 point, let's say 40567. Okay, so what is before the decimal point? So the dot is what we call the decimal point. Okay, and what's before it is the whole number part. Whole number part. And the one after the decimal point is what we call the decimal part. And what you need to understand is, in terms of place value, the 2 stands for 20, the 3 stands for 3 times 1. Now, what the 4 stands for, because it's in the first decimal place, is really 4 out of 10. The 0 is on the second decimal place, so it's 0 out of 100. The 5 is on the third decimal place, so it's 5 over 1000. So you notice that the position of the digit in the decimal part corresponds to the number of zeros in the denominator. So the 6 is in the fourth decimal place, so you can count. This is 1, 2, 3, 4, and that means there's 4 zeros at the bottom. Okay, so in terms of place value, these are what you call the tens. These are called the hundreds. So you notice we kind of name by what is in the denominator, except that we add the THS. Okay, so this is the thousands, and this is the 10,000s, and I'm missing one more, and that's the 7, and 7 being in the fifth decimal place is with 5 zeros, and that's called the hundred thousands. So just a reminder, the THS is only on the back word, it's not on the front. Okay, so we don't call it hundredth, we call it hundred and thousands. So if you are asked to write in words, so how do you write this number in words? Okay, so that's when you read the whole number part, so we call it 23. Now when we come to the decimal point, you use the word and. So that's the only time you use the word and, okay, in place of the decimal point. And then the trick is to read the decimal part as if it's a whole number. So 405, so think of it as decimal portion. The decimal portion that's over here, think of it as 40567 over, and because there's 5 decimal places, it's going to be 5 zeros. Think of it like that. So what you do is you read the decimal portion by reading the top first. So you're reading this like 40,567. But if you read the bottom number, that's when you read the place value as 100,000. So let's write this down. So it's 40,567. So you notice I'm reading this as if it's a whole number, but you do have to end with the last word, which is 100,000. Okay, so you don't put the place value for the 4 or the 0 or the 5 or the 6. You use the place value of the very last one, which is 7, and you read it as 40,567, and then the place value of the very last one. Okay, so this is the smallest place value. So once you understand the place value, what we can ask you is rounding. So we can say, can you round? Let's say 78.0567 to the nearest thousands. So think of the word thousand, that's 3 zeros, okay? So that means it's 3 decimal places. So go back to your decimal number and count to the third decimal place that's referring to this digit right here. So that digit 6 is in the thousandth place. So when you do rounding, what you do is you will look at the digit that comes after it. That's the digit 7. Now if this digit is 5 or more, so if it's 5 or more, that's when you carry up. Okay, so because it's a 7, I'm forced to add 1 to this. So what's my final answer? Is 78.057. And that's when we use this curly equal sign, which means approximately. Okay, so now that you have been introduced to decimals, let's talk about the operations. Whenever you are adding decimals, so adding or subtracting decimals, okay, the rule really applies the same as what we did for integers. If the signs are the same, you're supposed to add them, but you keep their sign. But if the signs are different, you subtract them. But so maybe I should write this down. So same sign is where you add, but you keep the sign. Okay, and if it's different signs, that's when you subtract, but you keep the sign of the larger absolute value. But there is a big difference between decimals and integers. When you're adding and subtracting decimals, so this is the big note, you have to align the decimal numbers by their place values. So take for example, you are doing let's say negative 49.231, and you wish to add to, let's say 15 or 5.32. Okay, so numerically larger number is the 49.231, so same thing, we're going to put that on the top, 231, and the smaller number is going to be at the bottom, which is 5.32. So you can see the signs are different, and if the signs are different, you are forced to subtract, but you keep the sign of the top number. Okay, so you take negative, but you have to subtract. But notice what I did, I need to line them up. So a lot of times we put a 0 to remind us that these are like decimals, as in you add enough zeros to make the two have the same number of decimal places. Okay, so now you're going to subtract downwards. So 1 minus 0 is 1, 3 minus 2 is 1. Now 3 cannot be subtracted from 2, so I'm going to borrow. So that's an 8, making this a 12. So 3 from 12 is now 9. 5 from 8, that's 3, and that's 4. So my final answer to this question is negative 43.911. Okay, so the big difference between integers and decimals is you must line them up by their place value. So here's a reminder for you. If I have, let's say, negative 2.005, and I wish to add to 7, for example. So numerically, 7 is the bigger number, so I put 7 on the top, minus 2.005. So observe, when you see a whole number by itself, it means the decimal point is right behind it. Okay, so that's why if you like, you can consider it as 7.000. So because the signs are different, you have to keep the sign of the top, but you must remember to subtract. So 5 cannot come from 0, you're going to borrow, there's nothing to borrow, so you're going to start borrowing from 7. That's when you send 10 over, and now you can send 1 over, which makes this a 10, and you can send 1 over, which makes this a 10, and now we're ready. So 5 from 10 is 5, 9 minus 0 is 9, 9 minus 0 is 9, point, and 6 minus 2 is 4. Okay, so your final answer is positive 4.995. So let's try one with the same sign. Take for example, if you have negative 5.217 and you have a 15.2, okay? So you can put the bigger number on top, smaller number below, it's up to you, but very important, you need to line them up. So you notice there's 2 empty spots. So normally, if you like, you can put a 0, okay, just to make them like decimals. Again, like decimals means they have the same number of decimal places. Okay, now look at these signs. Can you see they're the same? Okay, they're same signs. So when the signs are the same, you keep the signs and you have to add. So adding downwards, you have 714, and 15 with 5 is 20. So the answer to this question is negative 20.417. So in the case of multiplication, so let's remind you, multiplying decimals, okay? So in the case of multiplying decimals, for example, if I say, could you do 3.5 multiplied to 0.012? The way to multiply decimals, you're supposed to multiply as if they're whole numbers. So I'm looking at it as 35 and I'm looking at it as 12. So I'm disregarding the decimal places and the decimal point, and I'm just treating this as a whole number, 35 and 12, okay? And if you multiply this out, you're gonna have, let's say 10 and 7, and it's 5 and 3. So when I add this, will be 420. So this is going to be 420, and this is where you have to count, okay? So the number of decimal places in the product equals to the sum of decimal places in the factors. So if you count what's in the factors, there's one decimal place right here, 2, 3, 4. So that tells you that your final answer must have 4 decimal places. So counting from the back, that's important. Counting from the back, 1, 2, 3, 4, and then you put your point right here. Okay, that's where you put your decimal point. And any empty spaces, fill it with 0. So the answer to this question is 0.042, and you drop any unnecessary zeros. So drop unnecessary zeros. So in the topic of decimals, besides adding, subtracting, multiplying, so that this leaves me with dividing. So in dividing decimals, what you need to remember is that the divisor must be a whole number. So take, for example, if you gave me a number like 3.5 divided by, say, 0.0005. Okay, so we really don't care about the top. What we care about is the bottom. So the bottom is called the divisor, and you need to make sure it's a whole number. And to do that is where you move the decimal places, 1, 2, 3, 4. So you're trying to send it all the way to the back. But when you do that, you are making the top number go by 4 decimal places as well. So 1, 2, 3, 4. Okay? And in doing so, there is 3 empty gaps right there. So that's when you have to fill them with 0. So what this number transforms to, or this quotient, becomes 35 with 3 zeros, because now the decimal point is way back there, and you divide it by 5. Okay? So the process right here is really multiplying the top and bottom by something. So recall the original number is 3.5 divided by 0.0005. So what we're really doing is we're multiplying the top by 10,000 and the bottom by 10,000. That's what we're trying to do. Okay? So if we multiply the top and bottom by the same number, so that's okay, because we didn't change the result. But why is 10,000 chosen? Okay, why do we choose 10,000? Because this will bounce the decimal point back 4 decimal places. But in doing so, the top also has to bounce, okay, because of the effect of the multiplication. And hence, the result we get is 35,000 divided by 5. Now, this is something that you might have forgotten. So 5 goes into 35 7 times. Now these 3 zeros, all you have to do is write it back. So the final answer to my question is 7,000. So in any division, you notice it is possible that you end up with a decimal that doesn't stop, which we call a recurring decimal. So let me show you an example. So take, for example, we have the number, let's say, 2.35 divided by 0.6, for example. Okay, so let's try the trick. I'm looking at the bottom one. All I care is I want to make him a whole number, so I'm going to move by 1 decimal place. So the top is being moved by 1 decimal place, so it's going to be 23.5 divided by 6. Okay, so let's try our division. The divisor, this is what some students use to remember. The divisor, okay, is also the denominator, D and D. So that means 6 goes outside because that's the divisor, the one that you use to divide, and 23.5 goes inside. Okay, so make sure when you do division, the decimal point in the quotient is in the same location as the dividend, so it's right above it. So how many times does 6 go into 23? Okay, so 6 divides into 23, maximum would be 3 times, right? 3, so that's 18. And when you subtract, it gives you a remainder of 5. Okay, so once you put your decimal point, you can bring down the next digit. Observe, when I bring it down, I do not bring the decimal point with me. Okay, so I am now looking at the number 55. I don't look at it as 5.5. I look at it as 55. So 6 into 55 is how many times? So that goes in 9 times. Okay, so that makes it 54. Remainder 1. So this is where I'm allowed to add zeros because it's after the decimal. So when it's after the decimal point, you can add as many zeros as you want. So I just added one more zero so I can carry it down. 6 into 10 is once. Okay, so that gives me a remainder of 4. I'm going to carry down 0 another time, and it's 6, and it's 36, and then it's 4. And then very soon you realize, wait a minute, why is it always 4? Because this thing just keeps going on. So this is where you write it as a recurring decimal. So let me spell it for you. It's the recurring decimal. Sometimes we just call it repeating decimal. Okay, so we can call it repeating as in it repeats. And this is how you write it. You write it as 3.916, and 6 is the one that repeats, so we put a bar right across it. So that's about all I want to talk about decimals. You can look into the book for more examples, okay? But I just want to touch and go to give you an idea what to anticipate. The next part that is in 1.3, we want to talk a little bit about square roots, okay? So let's make sure you understand. For example, the number 49. This is a radical term, okay? And we call it a radical term because it's in the square root. The number inside has a name. We call him the radicand. So the radicand is referring to what's inside. Okay, so in this case, square root of 49, and you might already know this. So the way you have to think is what times what gives you 49? Which number times itself gives you 49? So the answer is 7. Okay, and the way you think is because 7, when you square it, makes it 49. So when we ask you the square root question, we're really asking you the reverse. Okay, so let's try another one. What's square root of 121? So remember how you're supposed to think? You have to ask yourself, what number times itself gives you 121? That's how you have to think. So what number times itself will give you 121? That's how you have to think. And the answer is 11. Okay, and so when you write it, you say square root of 121 is 11. So these are some of the perfect squares. So let me give you some more examples. Like for example, square root of 81. What times what gives you 81? So the answer is 9. So these are what you call square roots, okay? But watch out for numbers like this, okay? Square root 30, for example. So you notice 30, there's no answer, right? Because if you take a calculator and you press it, it's just going to be a decimal that goes on, and it doesn't have a pattern. So this is cannot be simplified, okay? So cannot be simplified. So later on in the book, we'll be spending an entire chapter on this. So don't worry about it. Right now at this point, all you need to know is what square root terms. Okay, so we'll be doing this more later in chapter 8. Okay, so this is where we devote the entire chapter talking about radicals and how to do them, how to solve them. Okay, and that's 3.3 for you.